In this video, I will be showing you how to construct a graph by hand and calculate the slope of the best fit line. The first thing that you want to do is identify your dependent and your independent variables. The independent variable is the thing that you change in an experiment, and the dependent variable is the thing that changes depending on what it is you've changed. The independent variable will always go along the x-axis, which is along the bottom, and the dependent variable will always go along the y-axis, or the side. In my experiment, I drank different amounts of soda, and I measured those amounts in milliliters, so that is the independent variable, and I counted the number of potty breaks that I needed based on how many milliliters of soda I drank. The number of potty breaks is the dependent variable. So the amount of soda would go on the x-axis, and the number of potty breaks would go on the y-axis. The next thing I need to do is orient my paper so I can fit all of the data on the sheet of paper. So you may need to move around things or make sure that your graph will be big enough for all of the information. The third thing you need to do is scale and label the x-axis. You need to make room for all of the data points, and you need to make sure you have the same scale throughout the entire x-axis. This means that each increment is the same size. You'll also need to label the independent variable and the units, label that axis. So I'm going to show you that here. I'm making my line for my x-axis. So this is going to contain the information regarding the amount of soda that I drank. I need to include all of the numbers from 0 to 1800. And I counted this out. It's a good idea to count out before you actually do your labeling. I counted this out, and I figured that I would have enough room if I gave each line or each square 100 milliliters. So I'm only going to label every other square. So I'm labeling them 200, 400, 600, 800, and so on. So that gives me enough room for 1800 milliliters, and I have an even scale throughout the entire x-axis. So every single square is equal to the same amount of milliliters. I'm going to label this amount of soda, which is in milliliters. Make sure I provide my unit. The fourth thing you need to do is the exact same thing, except now you're doing it with the y-axis. So remember, the y-axis is going to be the number of potty breaks that I needed to take. And I need to make sure I have enough room for 0 to 12 potty breaks. If I do this and count up by squares, so each square would equal 1 potty break, I have plenty of room for up to 12 potty breaks and even beyond that. So I'm only going to label 2, 4, 6, 8, 10 because I don't have enough room to write all the numbers, but each square is going to be equivalent to 1 potty break. And I can extend this all the way up to 18 potty breaks if I want to extrapolate some information from this graph. So this is going to be labeled the number of potty breaks, and the unit is actually potty breaks. It's a little strange because in this situation I'm counting something instead of measuring something. So I'm just putting the quantity of potty breaks on my y-axis. The next thing I need to do is provide a title for my graph. It needs to be prominent and centered. If you're not sure what to put for a title of your graph, make sure it includes both variables. For example, the amount of soda I drink versus the number of potty breaks I take. This is just a very generic way of titling a graph, but it should include the information about both variables. The next thing you need to do is plot your data. So each piece of information gets 1 dot. So the soda, the amount of soda I drink, so 250 milliliters, goes with 3 potty breaks. 390 milliliters goes with 4 potty breaks. 575 milliliters goes with 5 potty breaks. 800 milliliters goes with 6 potty breaks. 1150 milliliters goes with 7 potty breaks. So there's that dot. And then the last one is 1800 milliliters goes with 12 potty breaks. Finally, you need to add a best fit line or a curve. This is the part where you decide what it is your graph is telling you. In my graph, I have a straight line or a pretty linear graph. So I'm going to use a ruler and include information about the slope or a calculation on the slope. If your graph is curved or parabolic, you need to draw a smooth arc through the center of the data. And what that means is you want to make sure that the curve or the arc is not drawn point to point, but drawn so that there are about the same number of dots on either side. And it should be a very smooth or an average of all the dots. So I'm drawing this best fit line, and it doesn't have to be perfect, but this is the trickiest part to do because you have to kind of eyeball it. This is a positive or an uphill line, so that means I have a positive slope, and that actually makes sense because the more soda I drink, the more potty breaks I'll have to take. So now I have this line and I want to figure out the slope of this best fit line. And the way that I will do that is I will find 2 points on my best fit line pretty far apart from each other, so not right next to each other. And I'm going to make those points kind of an aqua color so you can distinguish them from the red plotted points. So these two sort of aqua colored dots are my 2 points that I'll be using to find the slope of this. And I chose points also that are on intersections of lines, of grid lines, because it's easier for me to know exactly what that line represents. I don't have to try to figure out the numbers in between. So I chose one at 1600 milliliters and 11 potty breaks, and 300 milliliters and 3 potty breaks. So now think back to algebra and what slope really means and how we calculate slope. Slope is defined as the rise over the run of a line. So we need to find that rise and we need to find that run and divide rise divided by run. The rise is the change in y and the run is the change or delta in x. So we'll start out with the change in y. That's the part that's vertical. So it goes from 3 to 11 in this, and that is a difference or a change of 8 potty breaks. So that is my delta y or my change in y. And you're just counting this triangle here that you created with the 2 points. The change in the x is the difference between 1600 and 300 milliliters. So this would be 1300 milliliters. Now, what do I do with this information? This isn't technically what I would want to represent in a lab report or something. I would need a decimal. So to do that, I take 8 divided by 1300, and I get 0.0062. So I'm going to round to 0.0062. And when I do that, I represent this as 0.0062. My unit is potty breaks per milliliter. And if you're wondering what to use as your unit, you need to use the same units that you used when you were figuring it out. So you had 8 potty breaks over 1300 milliliters. So my unit will be potty breaks per milliliter. And this is how you calculate the slope of any best fit line. If your line is going down, is a downhill line, you're going to have a negative slope. And if your line is going uphill, you're going to have a positive slope. So this is a positive slope.